this of essential R. In this presentation, I will be covering a lot of things. Uh, so let's get started. So I'll be covering R programming, that is R objects, character, numeric, integer, complex, logical, and so on, vectors, matrix, etc. Oops, that's not what I intended. Really, I'll be only covering essential R as the title of this presentation talks about. So I'll be talking only about what is needed uh, in R programming and in daily use. So I would just focus on the key topics that you would need to know in R. So for example, I would be focusing on vectors, how to subset vectors, data frames. Then I'll focus on key R packages that you will tend to use more often than any others. So one of them is dplyr. I'll also talk about other packages like lubridate and quantmod. And then for exploratory data analysis, we typically need baseplot and ggplot, two plotting mechanisms. Then I'll also touch about how to create R markdown files and create analytical reports and then publish these reports. And finally, I'll touch upon Shiny apps and some of the how to create an R package. So the key points about R is pretty forgiving in comparison to other languages like C, C++, or Java. So it does not have type definitions and declarations. It's not very strongly typed. And R is an interpreted language like Python, and every statement can be executed. And R does not have statement delimiter, so you do not need all the semicolons at the end of the line. You can start anywhere and you can continue on to the next line. Typically, there's no line continuation character also, and as long as you have an operator at the end of the line, you can continue on to the next line. And it works best with vectors. So typically, you tend to use sapply, tapply, and lapply for best performance. And to get started, I suggest that you download and install R. The latest version is R3.3.3, and you can download from the CRAN link. And also, I suggest that you install RStudio, which is one of the best IDEs for R. And this entire presentation, all the associated material, can be downloaded from GitHub. So you can either clone or download from GitHub, and this is the link. So it has 6 essential files and folders. The first is essential r.pptx, which is this presentation itself. Then I have essential r.r. This has some of the key coding constructs and programming constructs that you typically use in your daily programming. If you use R, of course, you could use more other techniques, but this is the more common R programming constructs, and I would suggest that you get more familiar with this. Then there's R markdown.rmd, which is where I show the more important markdown tips for creating markdown reports. Then I'll touch upon Shiny app, and I have a small toy example, test shiny app.zip. And then I have a test R package. Again, it's a simple R package, and I'll show you some of the most important elements if you want to create an R package. And finally, I have a CSV file which you can use to play around and get more familiar with R. And I suggest that you get used to these three friends in your programming journey. This could be in any language, but also in R. You would need to be very familiar with Stack Overflow, Google, and GitHub. Get an account in GitHub. This is the link, and these are some of the main GitHub commands. And so let's get started. And so I'm opening RStudio here, and this essential file is also there in this GitHub link which I had specified in the presentation. So R has two main variable types. One is the character variable type, and the other is numeric. So for character, I just assign x is equal to hello world, and a point of note is any line after this hash or pound statement is a commit. So here x is equal to hello world, and I just mentioned that can also use x is equal to hello world. So you can use the assignment operator as in other languages, or you use this specific less than hyphen which is used in R. So let's execute this line. So it is assign x is equal to the hello world, and if you want to display the value of a variable, you just type it on a separate line. So I type x, so I get hello world. And class x, this is, you will generally need to use to know what the type of the variable is. So if I do class x, it says it is character. Now I assign y to the value 2.5, and if I display y, it says it is 2.5. If I check the class, that is the type of this variable, it will say it is numeric. Then another important type in R which you need to get familiar with is vectors. Vectors is all elements have the same type, so you could have all character types or all numeric. So in the first case, my vector, they have all numeric values. So, and the way you do it is you say concatenate 1 2 3 1 2 4 5 8 10 12, any number of values, and if I display my vector, it will give this list of values. Or I can just give 2:12, so it will pick all values from 2 up to 12, and if I display it, it will show me these values. And the vectors can also be a character vector, so I just say C and I give strings within that, within parentheses, and if I display, I will get these character strings. So, and if I display the class, the type of my vector, it says integer because my vector had these integer values. And I can create these integer vectors also by using the sequence command. So for example, here I say sequence 50 by 5, which means I start a sequence from 5 and I end it at 50 and I increment by 5. So I do my vector here, so I see it starts with 5, 10, 15, 20 and so on. And the nice thing about R, which I find particularly useful is the fact that you can get help on any of the functions that you tend to use in R by just typing a question mark and the function name. So for example, we saw sequence. If I want to get more information on sequence, just type question mark sequence, and in RStudio this help will be displayed in this right hand corner. So you can see that it displays gives a description of this function. Then it gives you how to use it, the usage, the arguments from, to and by or length, and it also gives you, more importantly, gives you examples at the end, which is very useful typically when you are trying out any new command. You could use so you could use question mark and the function you are interested, or alternatively you can also use help and the within parentheses the function you are interested for the help. So again I get the same thing. So again, let us try a sequence, and I say start from 6, end at 43, and increment by 7. So it displays this. Or I can say start a sequence, end at 43, and I want the total number of numeric values from 6 and 43 to be 7. So here the total length is 7. So it starts with 6, ends with 43, and divides it into exactly 7 equal intervals. Then another important type you tend to use in R is matrix. So you have matrix here. I create a matrix, and the way you do it is you use the function called matrix, and I say use the vector from 1 to 20, so 1:20, and I say give it let the matrix have 5 rows and 4 columns. So if I assign y to this matrix, and if I check the class of this variable, it says it's a matrix, and I can display y. So y is now a matrix. It's from 1 to 20, and it has 5 rows and 4 columns as we specified. The next important data type is a list. In a list, it is a sequence of objects, but each object can be of different types. So one can be a numeric, another one can be a character, a third can be a matrix, a fourth can be a data frame, and so on. You can also have lists of lists. So here I just create a list with name is equal to Fred, it's a character, then my numbers, which is a character vector, then I say give a matrix, and finally a numeric vector. So if I display W, you will find that it has these four objects. The first is name, character vector. Second is my numbers, which is again a character vector with three strings. And the third is a matrix, and the fourth is a numeric variable. And the last data type is the data frame. And the data frame, you can visualize it as a table, an Excel table with n number of rows and m number of columns. And each column can be of the columns can be of different types, but all types within the same column must be the same. So here I am creating a vector here, a numeric vector D, and then I'm creating character vector red, white, red, and NA, and then finally I create a logical vector, that is F, and then I create a data frame. I just say my data frame is equal to data frame, and I give these variables D, E, F, and I can set the names of these columns using names within parentheses the data frame, and then I give the names for these columns using as a vector. So now if I display my data frame, I will have these three columns: ID, color, past, and ID is numeric what we assigned, and then we have color, which is this character vector, and past. So you see it has 4 rows and 3 columns, and each of the column is different, but all the elements within the same column are identical. So I can say class of my data frame. So quickly to recap, you see in R there are these major data types. The first is a character data type. We saw that we assign hello world. The second is a numeric data type. Then we can have a vector where you have elements, n number of elements, all of the same type. You can just use the C concatenate and give within parentheses the vector. It can be also a character vector where you can give strings. Alternatively, you can use sequence and say how you would like to increment it by, or you can give a total length and say how much should the length of the sequence be. Then you have the matrix, which is if you would typically use if you want to actually manipulate things in matrix. So for example, if you want to find the cost of a multivariate regression, you would use matrices. So you could do that, but R does have separate functions for that. And then we have list. As I said, you can have multiple objects, and each object can be of a different type. And finally we have data frames, and data frames basically it's a table, and in the table you can have multiple columns, and each column can be of a different type. Okay, so this is the major data types, and now we look at subsetting. How do you subset these different data types? So for example, a vector, if I create a vector using a sequence, and I say incremented by 2, start from 2 to 20, increment by 2, and here I display it. And if I want to get the fourth element, I just subscript it using 4. Alternatively, I can take a slice of this vector and just say show me elements 3 to 7. So I just within subscript I give 3:7. So if you see this within the subscript, you give a vector 3:7, and I display S. So it gives me just the elements from 3 to 7. That is one. And in one more thing to note in R is the subscript start with 1. Okay, so in this my vector 1, 2, 3, 3 starts with 6. So 3, 4, 5, 6, 7. So it displays that. Then I can also subset on a condition. So if I say give me all for my vector, just pick all the elements which are greater than 10. So I just say use the condition my vector greater than 10 and assign it to the value with to a variable called b. So let me execute this, and if I try to display b, it will be a logical vector where it will give false if it is greater than less than 10, and true if it is actually greater than 10, which is what we are interested in. Now I can use this logical vector to subscript my vector to get all values which are greater than 10. So if I do this, and if I try to display the value of a, I will find that it would have actually picked only the values that are greater than a. Alternatively, I can combine both statements. That is, I take my vector and in the subscript I give the condition my vector greater than 10, and if I do that, it will pick all values which are greater than 10. Another interesting way you can subset is For example, if you had a character vector with strings, I can just grep, typically like a Linux grep, pick all elements which have the string AB, start with the string AB. I just grep that, and then I just assign it to a variable, then I subscript this whatever the logical vector from this character vector, and I assign it to contains AB. And if I try to display contains AB, I will find that it actually does only have all the elements which have AB, start with AB. Or I can just combine both into a single statement. I can also do that. So it will just pick all the things which I have AB. And now another interesting thing I would like to show is, let us create another vector called my vector 1, and it starts at 3 and ends at 30 and increments by 3. So we have this, and we can do element-wise operations between two vectors. So my vector is, we saw it starts at 2 and ends at 20 and increments by 2. So now I can do an element-wise addition between my vector and my vector 1. Okay, I will add my vector and my vector 1. You will find that it does an element-wise addition. So 3 plus 2 is 5, 6 plus 4 is 10. So it does an element-wise addition. I can do an element-wise multiplication also. So if I do this, you will find that it does 3 into 2, 6, 6 into 4, 24, and so on. I can raise a vector to a particular power. So it has raised it to the power 3. Okay, so now we saw how to subset vectors and how to do this thing. Now let us look at how to subset matrices. Matrices, if you want to subset, let us say we create a matrix 1 to 20 with 5 rows and 4 columns. If I want to subscript, I just use the row and the column. Okay, so here I subscript the second row and the third column, which is the value of 12. Other operations in matrices typically which are, I create a matrix 3 by 3 matrix here, and here I create another matrix, again a 3 by 3 matrix with a sequence 5 to 10 and length 9. And these are some of the operations you can do. I'm going to execute it. You can try it out. A star B will do an element-wise multiplication, and A pound star pound B will do a matrix multiplication. You can try that out. Okay, now let us see how we subscript lists, that was the other data type we saw. So let us create the same list we created, where we have a character vector, then we have you have a character variable, a character vector, a matrix, and a numeric variable. If I want to subset, if I want to pick the second element of this list, I will use a double bracket. So W is the list, and if I do W double square bracket, and within that 2, it will pick the second element of this. The second element of this list is my numbers, which has a character vector 1, 2, and 3. So W2 will give me this specific character vector 1, 2, and 3. And if I want to pick a specific element with this character vector, I will just subscript. I will pick the second element of the list, and then assign it to a variable A, and then I will pick the second element of A, which will be the second element of the character vector. Alternatively, if I pick the third element of the list by doing double script and W double square bracket and 3, now B is a matrix, and I can subscript the matrix in the usual way. I have assigned it to B, and I just do B 2, 3, which will be second row, third column. I pick a value 12. Okay, so then there are now the third thing is, how do you subset data frame, which is what is the third data type we saw. And one cool thing about R, when you download and install R and you start using R along with RStudio, is that R already comes packaged with data sets. So you can check all the data sets that R includes by default by doing data parenthesis. So these are all data sets which you can use to play around with, to learn R and do some analysis. So for example, I am going to be using this data set called empty cars, which is shown here. see, so this is empty cars here, so you can I'm going to be using this, and the way you do that is you just attach empty cars, and I display this particular data frame. I just do head, means display the top 3 rows of empty cars. It has these many columns and this many I'm displaying the first 3 rows, and you see the columns have miles per gallon, the cylinder of this particular car, the displacement, the horsepower, etc. And if I want to subset this, I can say empty cars, and then I give that is the data frame name, the row vector and the column vector. So the row vector I can give 2 to 5, that is show me rows 2 to 5 and columns 3 to 6. So if I do this, it will pick the rows 2 to 5 of this data frame and columns 3 to 6. Alternatively, I can skip either the row vector or column vector here in this thing, and if I skip the row vector, it means show me all rows but only the columns 3 to 7. So if I do this, it will say display all rows of empty cars but columns, so displays all of this, but it displays only columns 3 to 7. So we saw the different data types. Basically, we saw character variable, numeric variable. Then we saw vectors, how to create vectors using sequences. Then we saw a matrix, how to create a matrix, what is a list, then a data frame, and then how to subset vectors, how to subset matrices, how to subset lists, and how to subset data frames. And now here are some important commands that you must get familiar with and partly memorize. One is to know in which is your current directory you're working on, and that you get by using get wd. Okay, so this will get the current working directory. So here I just say set working directory. Typically this is like a Linux or a Unix kind of a command. I just say set it to the current directory. I get the thing, or I can go up one directory and do a get a working directory. It will have gone one directory up. Then the other important thing you would need to do, is to show all the objects that are there in your workspace. Typically what happens is while you're working on a sufficiently large project, you tend to modify some of your objects, and then when you do a clean run, sometimes you may not have these modified objects and your code may fail. So it is good to know what are the objects that are there currently, and make sure that you are actually working on a fresh set of objects properly, the proper values. You can remove any specific object from your workspace by typing remove and then the object within quotes the object name, or you can remove all the objects, so you get a clean slate to start from. So just remove list is equal to ls parenthesis close parenthesis, and then you have another important command dir, which will show all the files and folders in your current directory. And here are some other important directory commands, like how to create a directory, how to create a file, to check if a file exists, and to rename a file. Obviously you can do this all whether you're on Linux or on Windows, but sometimes you may need to do it programmatically, and that is why I've just mentioned here, and so that you don't need to do a search. Okay, so to print an object, typically you use you can just display the variable on a separate line, it will display it, or you can use the print and the variable name. And then I would like to touch upon for loops, and the way you do for loops is for parenthesis I or j or any variable in 1 to 10. That means start from 1, go up till 10, and then do whatever statements you want to, and so you get the same see like open parenthesis and close parenthesis. Or you can also sequence along a vector. So you can just sequence along any, if you have a vector, character vector, you can sequence along and then go along the vector. But in R, you typically you need to avoid using for loops because they are very performance intensive, and I suggest that you go for using vector operations, for example sapply or tapply or lapply. Then how do you create functions? Functions, you just you give the name of the function, you assign it and say function, and give the list of arguments the function takes, and then do a computation within open parent, close parent, and whatever value you want to return, you make it as the last statement of the function. You don't need to give an explicit return here. You just give that variable in the last variable or the computed value in the last statement of the function, and that is the return value. So here if I do product of 712, it's going to give 84. I can also assign this. So here it will assign the product to P, and I can now display this. It's 234. Okay, so so far we have seen the different variable types, character, numeric, vectors, matrices, lists, and data frames. Then how to subset each of these, the vectors, matrices, lists, and data frames, and also some of the key functions like in the current working directory, and moving up a directory, or to remove particular objects. And I also showed you how to do create a function and define a function if you want to encapsulate a set of R statements, so that you can use it as a composite function, and how to use for loops and avoid for loops if possible.